Okay, good morning. I am not here today, so your lesson is going to be given to you through this video. We are going to do two examples together of a couple of things that we want to do with our implicit derivatives. And then I'm going to give you your first exposure to a true free response problem from a past AP exam. And I'm going to give you a chance to work together on that. So first thing I want you to do is copy down this equation. 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. If there's ever a moment where you need the sub to pause the video because things are going too fast or you have a question, please speak up. So what we're going to do with this equation is determine the points at which the graph has a vertical or horizontal tangent line. Okay, so if we're talking about tangent lines, the first thing we need is derivative. This is an implicit equation because of all of the y's that we have. So we're going to take an implicit derivative. So the derivative of 4x squared is 8x. The derivative of y squared is 2y dy dx because we are taking the derivative with respect to x, minus the derivative of 8x plus the derivative of 4y, so 4 dy dx, plus the derivative of 4, which is 0, equals the derivative of 0 is 0. Okay? As we discussed yesterday, you need to keep everything with dy dx on one side and anything without on the other. So I am going to keep 2y dy dx plus 4 dy dx over here. And then I'm going to add the 8 over and subtract the 8x over. Okay. We can then factor out the dy dx. Left over is 2y plus 4. Okay. And then our last step would be to go ahead and divide that over. So dy dx equals 8 minus 8x over, that is next, okay, 2y plus 4. Okay. Now, some of you may notice that we can reduce this fraction. Remember, it is not a big deal if you reduce or not. In AP Calculus, that's not what my main concern is. But since we can factor a 2 out of the numerator and we can factor a 2 out of the denominator, if you want to, you could reduce this to 4 minus 4x over y plus 2. We can factor a 2 out of the numerator and a 2 out of the denominator to cancel them out. Okay. All right, so here is our derivative. What are we going to do with that? All right, well, first of all, let's focus on horizontal tangent lines. We've done that before. If we have a horizontal tangent line, that means our slope is 0. Okay, so what we're going to do is we're going to take our derivative and set it equal to 0. So 4 minus 4x over y plus 2 equals 0. We kind of talked about this yesterday, but if we have a fraction that equals 0, then when I multiply that numerator or that denominator over, it really just matters where that numerator is 0. Okay? So you can see clearly that x equals 1 is where we have a horizontal tangent line. Okay? So just one spot, but I am asking for points. Okay? So what you're going to have to do with this x equals 1, we're going to have to figure out the y value. Okay? We can do that just fine, but we're going to have to go back to the original equation. So our original equation is 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. All right? Well, if we go ahead and plug 1 in for x, we get 4 plus y squared minus 8 plus 4y plus 4 is 0. Interesting. So you can see that the 4 minus 8 plus 4, those are going to cancel, and we are left with y squared minus 4y equals 0. Or y times y minus 4 equals 0. So this means y equals 0 or y equals 4, which means actually there are two places where we have a horizontal tangent line. We have a horizontal tangent line when x is 1, y is 0, and when x is 1, y is 4. Now let's go back to our derivative and talk about a vertical tangent line. Okay. A vertical tangent line means that we have a line tangent to our graph where the slope is undefined. Okay? So we want our derivative to be undefined. We kind of talked about this a little bit yesterday. Since we have a fraction, then we want our denominator to be 0, which means if we want undefined slope, y is going to need to equal -2 because that's what makes the fraction that is our derivative 0. Okay, so this would give us an undefined value. All right. So very similar to what we did over here, we're going to go ahead and plug y equals -2 into our original equation so that we can determine the x values for these coordinates. Okay. So our original equation, we have 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. Okay. Well, that's handy. We have the same thing happening again where we have 4 minus 8 plus 4. And so we are left with 4x squared minus 8x equals 0. So we can factor out a 4x, left over is x minus 2. So when x is 2 and x is 0, we have a y value of -2. So the coordinates where we have vertical tangent lines would be 0, -2, and 2, -2. For those of you who are curious about what is happening, if we think back last year, this equation, since we have 4x squared plus 1y squared, and we don't have an xy term, if we think back to our conic sections, since x squared and y squared are both positive, but they have different coefficients, this is an ellipse, okay? So it makes sense that we would have two vertical tangent lines and two horizontal tangent lines on an ellipse. Okay. All right. Some more fun. I guess before I go to the next fun piece of information, I will warn you that when you get a free response problem that involves an implicit derivative, more than likely they will ask you for either a horizontal or vertical tangent line, whether it be the equation or the coordinates, whatever it may be. That is a very popular piece to an implicit differentiation question. So this is going to pop up a lot in the next couple weeks. Okay. Okay. The next thing we need to be able to do is find the second derivative if we are doing implicit differentiation. Okay. So go ahead and write down y squared equals x squared plus 2x. All right, now some of you may be thinking, well, Mrs. Holman, can't we just square root both sides and have y equals plus or minus square root of x squared plus 2x? You don't want to do that because that means your derivative, or that gives yourself a piecewise function that you then have to take the derivative of. That is not what we want, okay? We want to keep this as one equation so we have one derivative to take, okay? So we're going to keep it like this, which means we're going to have to do some implicit differentiation. So the derivative of y squared with respect to x is 2y dy dx. The derivative of x squared plus 2x would then be 2x plus 2. So this one was nice, right? We only have one term with dy dx, and so all we have to do is divide over that 2y. Okay. If you want to make things simple, which is not a bad idea since we have to take the second derivative, we can reduce, we can reduce by factoring out of 2 of the numerator and denominator to cancel, and so we have x plus 1 over y as our first derivative. Okay. Now, we want the second derivative, which means we need to take the derivative of this right here. Okay, well that's fine. We have a quotient though, and so we're going to have to use the quotient rule. So the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Well, the derivative of y is dy dx. All over the denominator squared. So all I've done here is the quotient rule. However, we have to remember that we're still using implicit differentiation. So when we take the derivative of y, we have to write dy dx. Okay? Now, we know what dy dx is. So we can write y minus the quantity x plus 1 times x plus 1 over y. Because we know that is our dy dx. So we replace it with what we know about dy dx here, so that everything can be in terms of x and y in our second derivative. Okay, now I'm fine with you leaving it like this. More than likely, you're going to get asked to plug in a coordinate anyway, which means it's probably going to be easier to simplify with numbers than it is with algebraic expressions. So I'm fine with you leaving it like this until you know what you need to do with it. Okay, so this is what's going to happen next. I'm going to put something on the board. It's a free response problem that has 3 parts to it. I am going to have the sub time you for 15 minutes. When it comes time for the AP test, you will have 4 non-calculator questions and 2 calculator questions. For the 2 calculator questions, you get 30 minutes. For the 4 non-calculator questions, you get 60 minutes, which means you have an average of 15 minutes per question. So what I'm going to have you do, I'm going to give you 15 minutes to work together and see how far you can get on this problem. At the end of the 15 minutes, the sub will give you the solutions so you can compare what you did to what the solution is and how many points would you get on that free response problem. All free response problems have available of 9 points. So how many of the 9 did you get? Okay, I do want to tell you that all I expect is for you to try your best. There is a very low possibility that every single one of you will get all 9 points on this very first free response problem. A lot of it is figuring out how to answer the questions that they are asking. So all I expect is that you are trying your best and you are working together. If you get all 9 points, I'm very proud of you. If you don't get all 9 points, I'm still proud of you. Okay? So here we go. Once the sub pauses the video, he or she will give you 15 minutes. So I'll let that go ahead and happen now, and then you can check your answers at the end of the 15 minutes.